Okay, so this is part B of chapter 13 homework, and moving on with the first problem. Basically, I put all of my knowns on the left-hand side here, and I needed to solve for the mass of some of the trailer and the cab, or the truck. In this one, it wasn't separate. And then I was able to use my formula with momentum minus impulse times time equals momentum times potential energy, final. And I just solved for each of those things as I wrote out the equation and plugged those items in. I know that the impulse is the force times the mg, basically. With respect to time. And so I was able to solve for the force, and then part 2 asked for the time. And so since I knew my force, I just plugged it back into the equation and solved for t without, at position 2, without plugging in the 6 seconds. And I got my average was, or the change was 3 seconds. So moving on to number 9. This one I do want to understand better. I did this with my study group, and I'm a bit confused of when you can kind of say that the x direction is equal to the y direction in relation to forces, momentum, kinetic energy, etc. From my understanding, I just assumed that it was all the tension is going to be the same at those 3 different points because it is a rope. It can only go one direction. And so I used my conservation of energy formula and wrote down all of the values that were given. I was able to make 2 different equations, a series of equations, set those equal to each other, and solve for time. Once I had that time, then I could go back and solve for the actual tension. The only thing that confused me was right here, was the 2 of the potential energy of B, and how that was tied in. But I'm going to study that this weekend and understand it better. Number 10, down here. Basically, the bullet hits the block that's stationary and it swings upward. And it doesn't give us an initial or final velocity. So, we basically just start with all of our knowns, and we use the conservation of energy equation and basically get rid of all of the items that you do not need, which this was an easier process for me doing it that way. And then you have your formula, and you can plug that back in. With your potential energy at the start and finish, and you're able to get your gravitational potential energy. and then it asks for the impulse, so then we were able to get the impulse and the force on that directly after. The impulse is the integral of your force times distance. So once we found our actual distance, we were able to plug that into the impulse equation and get that. And then solve for the actual tension in the cable. Because it wanted the force on the cord. Number 11. This one I want to understand better. I don't fully understand it. And so basically I understand that the momentum is transferred, and so we're able to use our initial potential and impulse, and that stays throughout the contact. And so then that's transferred. We can write our two equations for ball A, ball B, and from there we can set them equal to each other and just look at one collision at a time. And we have a bunch of series of equations after you do that. And that's basically what it was asking for, is just solve for the equation. And from that point, we do it at collision 2. And then C just says solve for it with, let's see, with just n values. And so you're able to plug that in and get a formula there. For D, it wants you to actually solve for the velocity of part C, and so it gives you your impulse and the number. Number 12. So you have to solve for your initial velocity and then your relative velocity. So it started making more sense to me on this one, where I started just setting up everything my momentum and impulse before and after the impact, and then you're able to keep things more organized. So once I did that, I was able to get another series of equations, and I had enough knowns to where I could just find the actual momentum of the block and the sphere, both objects A and B, and then I was able to use that with the conservation of energy to find the actual height. Part B, the distance traveled by the block. Wrote my force diagram here and calculated the work done and basically the kinetic energy before and after, and was able to solve for X because the work done was force times distance. I was able to solve for that distance X. And that is everything for chapter 13.